Hello, today we're going to talk about absolute value inequalities. But before we begin, we want to start with what is an absolute value. So just a quick review, some students need to start with that. We're going to take a look at the absolute value of x equals 3. For some students, hopefully you've learned that the absolute value of x, by definition, means the distance of a number from 0. So if the absolute value of the number is 3, that means that the number must be 3 units from 0. Well, there's 1. But with absolute values, there's always 2 critical values. And negative 3 is the other one, because that is 1, 2, 3 units from 0. So we would say the absolute value of x is 3, and x can be negative 3. There are 2 solutions. And that is very important to remember when working with any absolute values. Now, if we're going to take a look at the inequality absolute value of x, let's suppose we're going to start with this, is less than 3. We'll start with something fairly simple. So where would we find the absolute value of x is less than 3? Again, I like to look at it visually. So let's take a look at a number line. Here's 0. And we all know that 1, the absolute value of 1, the distance is 1. So that would be a solution. So over here, I'm going to just create a solution set. So we know that 1 is in our solution set. We know that 0 is in our solution set. How about 2? Let's test 2. So if I have the absolute value, I'll do some of my scratch work over here and then erase it. So if I have the absolute value of 2 less than 3. So let's see, the absolute value of 2 is 2 because the distance is 2 units. Check. This is a true statement. Therefore, 2 is a solution. So I'm going to erase this. Let's take a look at 3. Would 3 be a solution? So we'll try that again. So if I have the absolute value of 3, is that less than 3? Well, the absolute value of 3 is 3. Is 3 less than 3? No. So that is a false statement. So 3 cannot be a solution. Could 2.99999 be a solution? Yes. Well, repeating bar over here. That could be a solution. But remember, absolute values have 2 types of solutions. We also have negative solutions. What if I make that a negative 3? Would negative 3 work? Well, the absolute value of negative 3, I'm over here, is 3. So negative 3 does not work either. Let me erase that though. Let's take a look at the absolute value of negative 1. So here we go. The absolute value of negative 1. Is that less than 3? Well, again, remember the definition means the distance from negative 1 to 0 is 1. Is that less than 3? Yes. So negative 1 is one of my solutions. And so probably you can figure out that negative 2 would be. And you probably can figure out the negative 3, which we talked about just a second ago, won't be. But negative 2.99999 would be a solution. And this is just some of my solutions. The solution set is not limited to these integers, for those of you who know what that word represents. So let's now take a look at it graphically. So we know 2 is a solution, we know 3 isn't a solution, but we know that negative 2.999 is. We know that negative 1 is a solution, negative 2 is a solution, and negative 3 is not a solution. But what we call these endpoints that are not included in our solution set, we call these critical values. Let me write that in blue. I like blue. So I'm going to say these are your critical values. Blue shows up. And I use that word because it's something you will see as you continue in math. So these are your critical values. Usually critical values are values that have endpoints and things like that point onto them. So we've looked at it graphically. We've looked at it in a solution set. But what would a solution answer look like with this kind of a problem? Let's go to yellow. Yellow. Okay. Let's see. Did I get it back to yellow? Not quite. Almost yellow. Not quite the same yellow. So now let's take a look at it. What would it be algebraically? So we've looked at it visually. Now let's look at it algebraically. We know that negative 3 and 3 are critical values. If you look, these are the numbers that represent x. Notice x is sandwiched between 3 and negative 3. I'm going to use that word, sandwiched. The and in there, it's sandwiched between those two values. So that would look like less than x less than 3. X is sandwiched between these two problems. That brings me to what I like to call a less than problem. I like to call an absolute value less than 3. I like to call that again, I like to use color. Let's choose maybe some more of a green color. We like to call this less, it's going to show up, less than. See that in there? Less than. Whenever you have an absolute value of x less than 3, you know it's a there's that and again, sandwich type problem. And later on we'll talk about x squared as well, and it follows the same pattern. Now this was a fairly simple problem. The absolute value of x is less than 3. Again, we have our critical values, 3 and negative 3. We have it's a less than, which means it's sandwiched between those two values. What's going to happen if you have an absolute value of x is greater than 3? Come back later and find the answer to that question.